Multiplying rational algebraic expressions. How do we multiply rational algebraic expressions? Let's have an example. We have here 8x squared all over positive 10 and multiply this by 35b squared all over 4x raised to positive 5. To multiply these rational algebraic expressions, first we have to factor out terms that can be factored before multiplying. We have here 8 and 4, so we can factor this out. 4 is common between the two terms, so 8 divided by 4, this will be equal to 2. 4 divided by 4 is 1. And then we have 35 and 10. 5 is common between the two. 35 divided by 5, that is 7, and 10 divided by 5, that is 2. Okay, what's left now with our equation will be 2x squared all over 2, and we have here 7b squared all over x raised to the power of 5. We can still factor out. We still have 2 and 2. So 2 divided by 2, okay, so this is 1. And we still have here x squared and x raised to 5. Okay, so x squared, this will now be 0. And this will be 5 minus 2, it's 3. What's left now will be 7b squared. X raised to 0 is 1. So this will be over x raised to positive 3. Therefore, 7b squared all over x raised to 3 is our final answer. Our next problem, we have here the quantity of x plus 4 all over 9x squared minus 25. And we are going to multiply this by 9x squared plus 30x plus 25 all over x squared plus 2x minus 8. So to multiply rational algebraic expressions, first we have to factor out terms that can be factored. Okay, x plus 4, this cannot be factored out, so it will remain as the quantity of x plus 4, whereas 9x squared minus 25, this can be factored out. The factor now, the factors of 9x squared, since this is a perfect square, its factors will be 3x, and multiply this by 3x. For 25, that is also a perfect square, its factors will be 5 multiplied by 5, and since this is negative, one of this will be positive and the other will be negative. And multiply this by 9x squared plus 30x plus 25. Okay, again, 9x squared is a perfect square. Its factors will be 3x and another 3x here. This is positive 25. Of course, it is a perfect square. And this, since this is positive, okay, so we have here the factors of 25, 5, and 5. And since this is positive and this is positive, we will have here positive and positive. We have factored out 9x squared plus 30x plus 25. Let us now try if the denominator is also factorable. So x squared is a perfect square. And the factors of x squared will be x multiplied by x. How about for negative 8? Okay, let's select factors of negative 8 wherein the sum will be positive. Now, since this is positive, the larger factor of positive 8, of negative 8, should be positive. Let's try negative 1 and positive 8. The sum of this is 7. How about for negative 2 and positive 4? The sum is positive 2. So positive 2 here is the same as our second term here. Therefore, we can use these factors. So our factors here will be minus 2 and positive 4. And then let us try if we can cancel out. Okay, we have here the quantity of x plus 4, and we also have here the quantity of x plus 4. We can cancel out the 2. This will now be equal to 1 and equal to 1. How about the quantity of 3x plus 5? We also have here the quantity of 3x plus 5. Yes, we can cancel this out. This is now equal to 1. Okay, what's left now for our numerator will be the quantity of 3x plus 5. Okay, so 3x plus 5 multiplied by 1, of course, that is 3x plus 5. All over, we have here the quantity of 3x minus 5 multiplied by the quantity of x minus 2. Okay, our numerator would now be 3x plus 5, but for our denominator, we have to multiply this. Okay, so let's multiply the quantity of 3x minus 5 multiplied by x minus 2. Can you still remember the FOIL method in multiplying binomials? Okay, so we will apply it here. So we are going to multiply first the first terms, 3x multiplied by x. This will give us 3x squared. And then this will be followed by the outer terms, or O. So we have here 3x multiplied by negative 2. 3x multiplied by negative 2, that is negative 6x. And then we are going to multiply the inner. We have here negative 5 multiplied by positive x. This will give us negative 5x. Negative 5x. And then we are going to multiply the last terms. So our last terms here will be negative 5 multiplied by negative 2. This will give us positive 10. Oh, positive 10. And we will have here 3x squared minus 11x and plus 10. Okay, so let's write here 3x squared minus 11x plus 10. Therefore, 3x plus 5 all over 3x squared minus 11x plus 10. This is our final answer. Let's try this problem. We have here m squared plus 4m minus 12 all over m squared minus 9. Multiply this by m minus 3 all over m minus 2. We can see that the numerator and the denominator here can still be factored. So we have first to factor this out before proceeding with our multiplication. The factors now of m squared plus 4m minus 12. The factor of m squared, of course, that is just m. Multiply this by m. And then the factor of negative 12. We will look for the factors wherein the sum will give us positive 4. Let's list down the possible factors of negative 12. But before that, since this is positive, the larger factor should also be positive. Let us try negative 1 multiplied by 12. Their sum here is positive 11. So this is not possible. Okay, let's try another one. Let's have negative 2. And then we have positive 6. Negative 2 plus 6, the sum is positive 4. Now, positive 4 is the same as our positive 4 here. So we can use these two factors. Okay, so we can put -2 and +6 here. Okay, let us now factor out the denominator. The factors of m squared, of course, that is m multiplied by m, and the factors of 9 is just 3 multiplied by 3, and since this is negative, we will have here positive and the other will be negative. And we will multiply this by m minus 3 all over m minus 2. Let's enclose this by parentheses so they can be called a quantity. And then looking at the numerator here, there is the quantity of m minus 2. We also have m minus 2 here. So this means that we can cancel this out, since m minus 2 divided by m minus 2, that is equal to 1. And we also have a quantity of m minus 3 here, and we also have it here on the denominator. This is also equal to 1. What's left now will be m plus 6. Okay, we can remove the parentheses left, and we have also here m plus 3. We cannot simplify this anymore, therefore m plus 6 all over m plus 3 is our final answer. And here's another example. We have here 4x squared minus y squared all over 5xy. Multiply this by y squared all over 2x minus y. To multiply this rational algebraic expression, first we need to factor out 4x squared minus y squared. The factors of 4x squared, this is a perfect square, so its factors now will be 2x, and just multiply 2x by 2x also. And then the factors of y squared, this is also a perfect square, so multiply y by y. And since this is negative, so we will have here plus and minus. And then we have 5xy as the denominator. Multiply this by y squared all over 2x minus y. Let's put a parenthesis here. And then we can see that we have the quantity of 2x minus y on the numerator, and it is also on the denominator. This means that we can cancel this out. This is now equal to 1. And what's left now will be 2x plus y or rather multiplied by y squared all over 5xy. But we can still cancel out y on the denominator because we have here y squared. So this will now be 2 minus 1. What will be left is 1. And we will have here 2x plus y multiplied by y all over 5x. And we will multiply 2x by y. So 2x multiplied by y, this is 2xy, plus multiply also y by y, so this will be y squared all over 5x. Therefore 2xy plus y squared all over 5x. This is now our final answer.